me tell you one thing. Always surround yourself with fighters. Fighters don't mean violent people. Fighters means the people who refuse to give up. They are the ones who see a problem and immediately start looking for a way forward. They don't waste time complaining. They focus on action. Their energy is contagious. When you start spending time with them, your brain begins to mirror their strength. You start thinking, if they can do it, then why can't I? And now coming to today's video, it is from eigenvalues and eigenvectors. And now I'm going to solve a problem related to Cayley-Hamilton theorem. So in this Cayley-Hamilton theorem, I'm going to verify Cayley-Hamilton theorem for the matrix A is equal to 3, 4, 1, 2, 1, 6, minus 1, 4, 7. And also I'm going to find out A inverse. See, first of all, what is this Cayley-Hamilton theorem statement states that? Cayley-Hamilton theorem statement states that if every square matrix satisfies its characteristic equation. See here, every square matrix satisfies its characteristic equation. So what is this characteristic equation? See here, the characteristic equation is nothing but modulus of A minus lambda I is equal to 0. A is nothing but the given matrix 3, 4, 1, 2, 1, 6, minus 1, 4, 7, minus lambda times of I. I means the identity matrix. Now I am going to multiply the whole matrix with lambda and subtract from this. So this is this. So I have subtracted lambda from the diagonal elements and remaining are same. 4, 1, 6 is same as 4, 1, 6 here. And 2 minus 1, 4 is same as 2 minus 1 and 4. Now I have to find out the determinant for this. For finding the determinant, see here, first of all I have taken 3 minus lambda. See, if 3 minus lambda is taken, so I have to close this row as well as column and I have to multiply these two. That is 1 minus lambda into this one is 7 minus lambda minus this is minus 24. And the next thing here is 4. So I have to take minus extra for this. So minus 4 times of, see I have to close this row as well as column. 2 into, so this will be 2 into 7 minus lambda minus, so this is minus 6, so this will become plus 6, clear. And the next thing here is, so we have to take 1, so this is 1 times of, so 1 I am not writing here, I am closing this row as well as column. This is going to become 2 4s are 8 minus, so this is minus of 1 minus lambda. So this is going to become 1 minus, so this is going to become 1 minus lambda. Clear? So everything is ready here. 3 minus lambda times of 1 minus lambda into 7 minus lambda minus 24 minus 4 times of, this is 2 times of 7 minus lambda plus 6 and the next one is plus 1 times of, this is 8 minus of minus plus 1 minus lambda, clear. So this is minus of minus plus 1 minus lambda. Now if I multiply, see what happens here. So this is going to become 3 minus lambda times of, if I multiply, this is a 7 minus lambda and this is minus a 7 lambda plus this value is lambda square minus 24 minus 4 times of, so this is 2 7s are 14 minus this value is 2 lambda plus 6 and this is 8, so this value is 8 plus 1 minus lambda, clear. So this is equals to 0 and see here, now this value is going to become 3 minus lambda times of, here there is 1 lambda minus, so this is 8 lambda and see clearly it is, if you see this one 24 minus 7, so this value is going to become minus 17, clear. Minus 4 times of, if you see 14 plus 6 is 20 minus 2 lambda and this one, so this is 9 minus lambda is equal to 0, clear. And now I am going to multiply with 3, so this is going to become 3 lambda square minus 24 lambda minus 3 7s are 21 2 and this is 5 and this is minus lambda cube and this is minus into minus plus, this value is 8 lambda square and this is plus 17 lambda and this is minus 80 and this is minus of minus plus, this value is 8 lambda and this is 9 minus lambda is equal to 0, clear. And now see here, there is one single lambda cube here. So if you observe, there is only one single lambda cube. Now I am going to write as minus lambda cube. And if you start this one quotient, collecting quotients of lambda square. So here is a lambda square, here is a lambda square, That's it. So here 8 plus 3, the value here is 11 lambda square. And if you start searching for quotients of lambda, so this is minus 24 plus 17 plus 8 plus 1. So see, this is going to become, this is minus 24 plus 17 plus 8, and this is minus 1 lambda. And if you go with constants, so this is minus 51, and see this is minus 80 plus 9. Clear? So I am writing in one bracket, this is minus 51 minus 80 plus 9 is equal to 0. Clear? And now see here, so this is going to become minus lambda cube plus 11 lambda square. If you start searching, so this will be 25 minus 24 plus 24, and this is minus 24. So this is minus 24 and this value is plus 24 lambda. And if you observe this one, so this is minus 51 minus 80 plus 9, and this is going to become minus 122 is equal to 0. So here if I cancel this one, this is minus lambda cube plus 11 lambda square minus 122 is equal to 0. And see, if I write like this, so if I multiply with minus, so this is lambda cube minus 11 lambda square plus 122 is equal to 0. So this is our characteristic equation. See here, what is this? This is a characteristic equation. So here, according to the Cayley-Hamilton theorem, so every square matrix should satisfy the characteristic equation. So in place of lambda, if I substitute A, and if I found that its value is 0, then we say that Cayley-Hamilton theorem is verified. So in place of lambda, I am going to substitute A. So here, what is the characteristic equation here? So if you see here, this will be lambda cube minus lambda square plus 122 is equal to 0. So here in this, if I substitute the value A here, so what is our A here? So if I substitute A, so this is going to become A cube. So I'll check whether it's going to satisfy or not. So in place of lambda, if it satisfies, so it should be equal to 0. So first I need the value of A cube as well as A square. For finding A square, so A square value is ready as A into A. So A square is nothing but, what is our A value? So this value is nothing but 341. This is 216. This is minus 147. Clear? Minus 147. Clear? So I have to write it for 2 times and I have to multiply. This is 341. This is 216. And this is minus 147. Clear? And now for multiplying, see here. So I have to multiply these two. So here every time I have to go like this. So A square value is equal to, see this is 3 3s are 9 plus 4 2s are 8. This is 1 into minus 1 minus 1. So this is 3 4s are 12. This is 4 1s are 4 and this value is plus 4. And see, this is 3 1s are 3 and this is 4 6 are 24 and the value here is plus 7. Clear? And the next one, 3 2s are 6. And this is plus 1 into 2 is 2 and this is minus 6 and this value is 8 and this value is plus 1 plus this value is 24 and this value is 2 plus this is 1 into 6, the value here is 6 plus this value is 42. And next one, if I multiply, so this is minus 3 plus value 8 and this value is minus 7. Clear? So this value is minus 4 and this is plus 4 and this value is plus 28. And this, if I multiply minus 1, so if I multiply this value is 24 and this value is 49. Clear? And therefore our A square value is going to become, so here this value is a 17 minus 1, the value here is a 16. The value here is 16. So this is 8 plus 12. The value here is 20. So this is 27 plus 7. The value here is 34. And the next one here, if I cancel these two, the value is going to become 2. And this is 25 plus 8. 25 plus 8, the value here is 33. And here 8 plus 42, the value here is 50. And the next here is minus 10 plus 8. Here this is minus 2 and if I cancel, so this is going to become 28. Clear? And this is 23 plus 49. Here the value here is 72. So here this is a 72. So this is our a square value, and next I need a cube. So now I'll substitute a square value here, and now I'm going to substitute a cube value for finding a cube. So here a cube value is also the multiplication. A cube value is nothing but a square into a. So a cube value is nothing but, what is a square? This is a 16, 20, this value is 34, this is 2, this is 33, the value here is 15, this is minus 2, 28, and this value is 72. So this is our a square. And what is our a value here? And let me show you the way a value is nothing but 3, 4, 1. This is 2, 1, 6. This is minus 1. This is 4 and 7. Clear? So now I am going to multiply these two. For multiplication, see here. So these two are sleeping lines and these two are standing lines. And see, a cube value is going to become, now a cube value I am going to show. So this is a 16 3s are, the value here is 48, and 22s are, the value here is 40, and this one is 34 into minus 1, the value here is minus 34. So 16 4s are, the value here is a 64, 20 into 1, the value here is 20, and this is 4 4s are 16, 1, 12, 13, so 136. The value here is, this is plus 136. And if I multiply, so this is a 16 and this is 20 into 6. The value here is 120. And here the value, see, observe, 4, 7 4s are 28, 2, 21, 22, 23. So here this is 23 plus 238. See here, 2 into 6 is 6. 33 into 2, the value here is 66, and this value is minus 50. See here, if I multiply, this is 8, 33 into 1 is 33, and the next one here, this value is 200. Clear? This is 2 into 1 is 2, 33 into 6, 6 3s are 18, 1, 18 plus 1, 19, 198. Clear? So 50 into 7, the value here is, this value is 350. Clear? So this is minus a 6, and this is 28 into 2, the value here is 56, and this is minus a 72. So if I multiply, this is minus 8, 28 into 1 is 28, and this value is 72 into 4. So if you see, 4 2s are 8 and 28. 284. So the value here is 284. So 28 into 4 is nothing but 28. So 4 into this one. So 4s are, wait. Yes, 4 2s are, the value here is 8, and this is 4 7s are, the value here is 28. And the next thing is minus 2 into minus plus 1, 28 into 6. So this is 168, 48, 4, 12, 13, 14, 15, 16, correct. And next one is, this is 14, 1, 49, 50. So this value is 50. So 504. So these are the values. So here I am going to calculate this one, a cube. So a cube value is very clear as, so if I add up these two, this is 88 minus 32, and this one, the value, if I add each and everything, this is 220, and this value is 374, and this value is nothing but 22, and this is 241. 241, so this value is 550, and this is minus 22, and this value is 308, and this is a 670. So I got the value, this is 88 minus 34, the value here, a cube value is, so if I subtract 4, 5, so this is 54, this is 220, this is 374, this is 22, this is 241, this value is 550, this is minus 22, this is 308, and this is a 670. So this is our a cube value. So we got a square value ready and a cube value is also ready, and now I am going to substitute here. So in this equation, if I substitute, see what happens here. The first thing here is, first I have to note a value. So what is our a value here? The first a value is very clear as, this value is 341. this is 216, this is minus 147. And a square value, let me show you. A square value is this one, as this is a 16, 20, this value is 34, this is 2, this is 33, this value is 50, this is minus 2, this is 28, 72. So here a cube value is, what is our a cube value? So a cube value, I'm copying here, this is 54, this is 220, this is 374, this is 22, 241, this value is 550, this is minus 22, this value is 308, this is 670. So here, what is the characteristic equation? The characteristic equation is like this, that is a cube. So here, this value is a cube minus 11a square plus 121. So into I, so we have to multiply with identity matrix here. So a cube value is ready as, so what is our a cube value? I'm copying here. This is 54, this is 220, this is 374, and this value is 22, this is 241, this is 550, and this is minus 22, this is 308, and this value is a 670. Minus 11 times of what is our a square value? This is our a square value. This is a 16, 20, this value is 34, this is 2, this value is 34, and this is 50, this is minus 2, this value is 28, and 72 plus 122 into I, identity matrix, 122, 0, 0, 0, 122, 0, this is a 0, 0, this value is 122. Now see here, let me multiply with 11 here. So if I multiply with 11, see what happens. So this is going to become, so this value is 54, this is 220, this is 374, and the next one, this value is 22, this is 241, this is 550, and this is minus 22, this is 308, and this value is a 670, minus, see here, minus, if I multiply with 11 here, so if I multiply with 11, then see, this is 11 into 16. You can use your calci. This is 176, 11 into 20. The value here is 220, 34 into 11. So this value is nothing but 374. 374, and this is 22, and 11 into 33, this is 363, and this value is 550. So this value is 550. If I multiply the value here with 11, this is minus 22, this value is 308. If I multiply 11 with 72, this is a 792, plus the value here is 12200, this is 0, 122, and this is 0, 0, this value is 122. Clear? Now I have to use a single matrix here. So if I use a single matrix, so this is going to become, so I can use this one. So if I use a single matrix, this is 54 minus 176. Clear? This is 54 minus 76 plus 122. And the next one is, this is 220, and this is minus 220 plus 0, and this is 374 plus minus. So this is minus into 374 plus 0. So this value is 0. Clear? And the next thing here is 22. So this value is 22 minus 22 plus 0, and this is 241 minus, so this is 363, and this is 122. And the next thing is, this is 550 minus 550 plus 0, and this is minus 22, minus of minus, plus 22 plus 0, and this value is 308 minus, this is 308 plus 0, and this is a 670 minus 792 plus 122. Clear? So here, so this is going to become, this is 54 plus 54 plus 122 is nothing but 176 minus 176, and this value is 220 minus 220, and this value is 374 minus 374. This value is 22 minus 22. This value is 308 minus 308. And so if you add these two, this is 297. So this is 792 minus 792, and this value is minus 22 plus 22, and this value is again, see, this is 22 minus 22. So if I add this one, the value here is, this is 363. So this value is nothing but, this is 308 minus 308, and this value, a small mistake here. So here this is 363 minus 363, and everything is okay now. So okay, I've copied here like this. So this value is 550 minus 550, and this value down, the value here is 792. So this is 792 minus 792. If you observe this one, you can cancel each and every value. So if you see, you can cancel all the values here. All the values got cancelled, and therefore, so we got the value as a 0, 0, 0, 0, 0, 0, and this is 0, 0, 0. So we have started from here. So which thing? So this is a cube. So a cube minus 11a square plus 122. Here we have substituted a value and we got 0. So this is the characteristic equation in which the square matrix is replaced. Therefore, every square matrix satisfies its every square matrix satisfies its characteristic equation. Hence, Cayley's-Hamilton theorem is verified. Hence, Cayley-Hamilton theorem is verified. Cayley's-Hamilton theorem is verified. Clear? So here everything is ready here. Everything is ready. So each and every step I have explained you, a cube, a square and a. And now the last thing is we have to find a inverse. For finding a inverse, see here. So we have the characteristic equation as this one, as a cube. See here, the characteristic equation just now we found as a cube minus 11a square plus 122 is equal to 0. Now both sides I am going to multiply with a inverse, as I need a inverse. So this equation I am going to multiply with a inverse. So if I multiply with a inverse, what happens here? So if I send a inverse inside, so this is going to become a square minus. So if I send a inverse, so this is a plus 122 into a inverse is equal to 0. So strictly I need a inverse. So I am sending these two terms to other side. So 122 a inverse is going to become 11a minus a square. So this is 122a inverse is equal to 11 times of a. So what is a here? So we have all the values ready. A square, everything is ready here. So a value is nothing but 341. So this value is nothing but, this is 341, 216. This is minus 147 minus a square. So what is a square here? This is a 16, 20. This value is 34. This is 23350. 23350, this is minus 228 and 72. See here, 11 times of a minus this one. So I am going to multiply with 11 this time. So here, this is 122a inverse value is equal to, so this is 33, this is 44, and this value is 11. So if I multiply, this is 22, this is 11, and this is 66, this is minus 11, this is 44, and see here, this value is a 77 minus. So this is a 16, 20, 34, this is 2, this is 33, this value is 50, this is minus 2, 28 and 72. Now if I write in one bracket, so this is 122a inverse is equal to, this is 33 minus 16, this value is 44 minus 20, this is 11 minus 34. So this is 22 minus 2, this value is 11 minus 33, this is 66 minus 50. So this value is minus 11, minus of minus plus 2, and this value is 44 minus 28, and this is a 77 minus 72. Clear? And now see here, the values are very clear. This is 122. A inverse value is equal to 33 minus 16 is a 17. So 44 minus 20 is nothing but 24. So this is minus 23. So this value is minus 23 and this is plus 20 and this value is going to become minus 22 and this value is become plus 16 and this is minus 9 plus 16. The value here is 16 and this value is nothing but 5, and therefore, so I am sending this 122 down, so other side it will divide. Therefore A inverse value is going to become 122. 122 times of 17, 24 minus 23, this is 20 minus 22, 16, this is minus 9, 16, and this value is 5. So you can do along with me and you can check the answers. So if you and me matches, then definitely you can solve by your own any problem of any kind, and these are the most important questions, repeatedly asked questions. So if you practice from the playlist, definitely your score will be very high, very more. And if you really like, you know what to do, please raise your thumb, pass it on to your friends, and subscribe to this channel, and stay connected for more important videos. Thank you so much for your support.